one and all. So the first problem will solve on based on the force analysis of the IC engine, right? Okay. So I think the screen is visible in front of you. Maybe there is some technical problem. 1 second. Guys, once again, hold on. There's a problem for my, I think, PowerPoint. I'm just opening it up. Okay. Now I guess the screen is visible to you. Is the screen visible to you? Anybody please message me?
Yes, sir.
Okay. But again, there is a problem. Okay. So let's start with the problem number one. The vertical double acting steam engine. So you can see here it is a vertical double acting steam engine, right? Has a cylinder 300 mm diameter and 400 mm strokes and runs at a 200 rpm. The reciprocating part has a mass of 225 kg and the piston rod is 350 mm diameter. The connecting rod is to 1.2 meter long. When the crank has turned through 125 degree from the TDC, crank has turned through 125 degree from TDC, the steam pressure above the piston is 30 kN per meter and below the piston is 1.5 Newton per meter square. Calculate the effective turning moment on the crankshaft, right? So basically we have to calculate all the forces first of all acting on the IC engine. So first of all, let us start. D is equal to 300 mm. So a steam engine has a cylinder diameter 300 mm. That is the cylinder diameter is also called as a cylinder bore. It is also called as a cylinder bore. You may study this in your module number 4 or 5 of IC engine about the cylinder bore. So cylinder bore is also called the cylinder diameter. So it is given to you. So we consider it as a capital D 300 mm. Then they have given a 400 mm stroke. A 400 mm stroke means what? It's a distance traveled by the piston from moving from TDC to BDC, right? When the piston moves from TDC. So basically these are the concepts of IC engine, which again I am saying you will learn in the detail in that subject. But here I am giving you small insights, right? So from when the piston is moving from TDC to BDC or vice versa, whatever the length the piston is traveling inside that engine cylinder, that is stroke 450 mm given by L. Okay. Now R, what is R? R is equal to crank radius. Now you always remember that is R is always equal to L by 2. This is the half of the stroke. R is always equal to the half of the stroke. Okay. You will do the analysis regarding this in your IC engine. So these are some points which we may not have been covered while doing an analytical, when doing an analysis in the or the derivation. So you remember here. So 225 mm, 0.25 meter, and running and runs at a 200 rpm. So an engine is running at a 200 rpm. Okay. So first of all, find omega. So omega is equal to 20.95 radian per second, right? Next, MR. The connecting rod, the reciprocating parts has a mass of 225 kg. Okay, so reciprocating mass, how we are denoting? We are denoting by MR. So you can see MR is equal to 225 kg. The connecting and the piston rod is 50 mm in diameter. So diameter of the piston rod. So let us consider the diameter of the piston rod is D, small d, 50 mm, is equal to 0.05 meter. Okay, and the connecting rod is 1.2 meter long. So let us say that small l. What is small l? Small l is nothing but the length of the connecting rod. Okay, so this I have. Then when the crank has turned to 125 degree from TDC, the crank has turned from 125 degree from TDC. What does it mean? It means that the piston is turning, moving from TDC to BDC, right? The piston is moving from TDC to, the crank has turned through 125 degree from TDC, right? So this is nothing but a theta. 125 degree is nothing but a theta. So crank has turned through 120 degree from TDC. Means what? The piston will move from TDC to BDC. So tell me, which will, where will be the what? How will be the stroke acting? Downward stroke or upward stroke? Yes, the stroke will be downward or upward. Anybody? The piston is moving, the crank has turned through 25 degree from TDC, they are saying. Means what? The piston will move from the TDC to BDC. So it's upward stroke or downward stroke?
Downward.
Downward.
So you will take a weight positive or negative as per our theory. Hello? So basically what I said, when you are, I have already explained in the last lecture also at the end of that lecture. So when the stroke is downward, take weight positive, WR, and take weight negative, okay? And when the masses are accelerating, you should take a negative sign. In case of the FL, that is a net load acting on the piston. And when the masses are retarding, you should take a positive sign, okay? So that what I have explained in the later case. Now next. First of all, find out, next, what they have given. Yeah, the steam pressure above the piston is 30 kilonewton meter and below the piston is 1.5 kilonewton per meter square. So what they have given, so this is nothing but the pressure, okay? Pressure difference, they have given you the pressure difference. Let's try to understand this. They have given you the pressure difference. So basically they have given P1 is equal to, I will draw a diagram. Let us say this is a, now this is a vertical engine, na? So let us say this is a cylinder, this is a piston, this is a piston, this is a cylinder, okay? And right. So now they have given this you, this is nothing but the upper side, they are saying this is a P1 and this is nothing but a P2. Now you know this all, okay? So they have given you P2, they have given you P1, okay? So now tell me, net gas pressure acting on the piston. So net, we know, I have already explained this, right? In case of the horizontal engine, listen once again. Net gas pressure acting on the piston. Net gas pressure acting on the piston. How will you calculate net gas pressure acting on the piston? That is PG. Okay, let us consider the PG. So that will equal to P1 minus P2. Okay. In case of the horizontal engine, it will be like this. Okay. See, I am not going to solve all type of problems. So I am trying to cover everything in the single problem. So whatever may be the type of the problem arriving in your exam or maybe in your theory, you can solve. So in case of the piston, let us say this is a P1, this is a P1, this is let us say P2, horizontal engine, right? This is a P2. So same, the net gas pressure acting on the piston will be P1 minus P2, right? So this P1 they have said acting at the, where they acting? Pressure above the piston. So P1 is above the piston, P2 is below the piston. Similarly, in case of the horizontal engine, this P1 is acting on the cover side. It is called as the cover side of the piston, and this is called as a crank side. This is a crank side. Similarly, this is also called as a cover side or top side, right? And this is P2 is acting at the crank side or the bottom side also, you can call it as a. Similarly, P1 is at the cover side, or you can say behind the piston, and this is beyond the piston. Okay, so I hope you understand this. So always you have to calculate the net gas pressure. Sometimes they may give you the net gas pressure acting on the cylinder. They may directly give you the PG. So remember what is given. Sometimes they will give you the P1 and P2. So PG is nothing but a net gas pressure acting on the piston. So you have to understand what is given. Okay. Now once you calculate this, what is the next thing? Now we know that Okay, now we know that F is nothing but a net load on the piston, net load on the piston. Now this FL is nothing but a net load on the piston, right? You can call it a net load on the piston or net gas force acting on the piston. It is also called as a net gas force acting on the piston. Okay, so basically how you calculate this? This is nothing but the Pg multiplied by area. That is a net gas pressure acting upon the piston multiplied by area. So this FL is equal to Pg into area. So Pg is nothing but P1 minus P2 multiplied by, and what is area? Area is always pi by 4 into d square. Right? This area is nothing but a pi by 4 into d square. Okay, where d is nothing but the diameter of a cylinder. Diameter of a cylinder. Right? Now, so in this case, we have considered as a capital D, no? Up until the capital D considered. So pi by 4 diameter of a cylinder. So remember this properly, okay? And then you take this FL plus or minus. Now again, one more question to you. When you will take this FL plus minus, when you are taking this minus, when the masses are accelerating, and when you are taking this plus, when the masses are retarding, okay? It is clear? Okay, chalo. So I hope it is clear, everybody. It is clear or not? Okay. So first of all, find out the area of the piston. Okay. Now area of the piston. Now see, basically here you try to understand that they have given you two diameters. They have given you two diameters. The first is the diameter of the engine cylinder, 300 mm diameter, and they have also given you the piston rod diameter. So they have given you capital D and small d. Okay. Now you try to understand that if only capital D is given, what is capital D? Diameter of cylinder. बघा मी काय सांगतो लक्षात घ्या. जर तुम्हाला diameter of cylinder दिला असेल and let us say P1 and P2 is given, to directly calculate FL is equal to pi by 4 D square multiplied by PG, when PG is nothing but the P1 minus P2. Okay, but when small d is also given, what is small d? Small d means what? Diameter of the piston rod. So you cannot directly use this formula. In that case, which formula you will use? Which formula you will use? The formula which I have explained you in the derivation. Okay. So is it clear if only diameter of the cylinder is given? Is it clear? Which formula you use first of all? In this case, I will explain. Tell me if only the diameter of the cylinder is given, P1 minus P2 is given. Have you understand how will you calculate the net gas force acting on the piston FL? Message me yes or no. Yes? Hello? Okay. Now, but in this case, they have given you the capital D and the small d. So how will we start? First of all, find the area of the piston. Area of the piston is equal to pi by 4 capital D square. So pi by 4 into 0 part. Okay. Similarly, area of the piston rod. Now they have given you the diameter of the piston rod also. Okay. Basically, what happens? This area of the piston rod is very, very small diameter. So you can neglect it if it is not given in the question. But here it is given, so you cannot neglect. So small, let us consider it as a small area. Small area is, let us say, pi by 4 d square. So now I have got the area of the piston rod and I have got the area of the piston. Okay. Now you find out FL. Now you have to use this formula. FL is equal to P1 minus P1 A1, that is a P1 into area 1 minus P2 into A1 minus area. So this is the formula what I have derived. Okay. And if the small a is not given, like use this formula, FL is equal to pi by 4 capital D square into PG. Okay, you can use directly this formula. So try to understand where and where, how you have to modify the formula. Okay, but now here small a is given, so use this formula. So you know what is area 1, you know capital area, P2 माहिती आहे, आपल्याला सगळं माहिती आहे, मला FL मिळाला 20. Try to understand, take this pressure in Newton per meter square and take area in meter, take the SI units, then and then only you will get FL. Now you have got FL. Okay. Now what is N? N is nothing but obligatory ratio. It is L upon R. So what is N? N you are getting 5.8. What is L? Length of the connecting rod. R is nothing but a crank radius. So now you got N and you got FL. Okay. Clear? Next. Now you got this. Next one. Now inertia force. Now inertia force on the reciprocating part, you have to remember this formula. What is the inertia force? You know that inertia force, Fi, inertia force is always equal and opposite to the accelerating force, but opposite, so minus sign. So you know what is inertia force, what is D'Alembert's principle, I've already explained. So that we have derived this formula from the dynamic analysis of a slider crank mechanism. So Fi is equal to mr omega square r cos theta plus cos theta. So you have to remember this formula. Okay, so put everything. Now here you are getting a minus and doesn't matter. Inertia force is a minus or plus. Okay, because you know that uh, when the masses are accelerating and when the masses are retarding, okay, the cycle changes. So in the first half part they are accelerating, in the second half part they are retarding. So sometimes you will get a plus sign, sometimes you will get a minus sign of a inertia force. So it doesn't matter because this minus sign means what, it is equal and opposite to the this one. Okay, so this minus sign means that the forces are accelerating, the masses are accelerating. So when the masses are accelerating, you will get this minus sign. Remember this. Okay. So already we know theta. Theta if you take in degrees, we know what is omega, we know what is mr. Mr should be in kg, r should be in meter. So kg, radian per seconds. This is in meter and this is in degrees. Okay. So n is dimensionless quantity. You are getting this minus 170 Newton. Okay. Is it clear? Clear? Is it clear? Clear? Okay. Clear? Now use the formula. Now we know that for a vertical engine, net force on the piston effort. Now first step number 1, Fp. So Fp is equal to Fl minus Fi plus Mr into G. Okay, Fp is equal to Fl minus Fi upon Mr into G. Okay, so basically we know that when it is accelerating, okay, when the masses are accelerating, we take a minus sign. Okay, and when there is a downward stroke, we take a plus sign, Mr into G. Okay, so accordingly this formula arrives. So Fl minus Fi, because the masses are accelerating, plus Mr into G. Right, and as I said earlier that if sometimes in the problem they have not given whether the masses are accelerating or whether the masses are retarding, so we consider it as a accelerating. Okay, and obviously they will give you whether it is a downward stroke or upward stroke. So accordingly take this sign plus or minus. Okay, now they haven't given you the friction. त्याच्यामध्ये कुठेही त्यांनी फ्रिक्शनल फोर्सचं काही म्हटलेलं नाहीये. So we will not consider the frictional force. Okay. So calculate. So FL you know that 2018 minus Fi plus Mr into G. So you are getting Fa. So net force acting on the piston is 18397 Newton. Okay. Is it clear? I hope it is clear to you. इथपर्यंत क्लिअर झालं का मला सांगा म्हणजे आपण पुढे जाऊया. So first step, this next step. Now find phi. First of all, you have to find what is phi. It is nothing but an angle. This is a, let us say this is a FQ connecting rod, and this is a, let us say, PO line of stroke. So angle between this connecting rod PC and line of stroke is nothing but a phi. That is nothing but a angle of inclination. So we know that you remember this formula. Sin phi is always equal to sin theta upon obliquity ratio. We know what is theta. We know what is n. We will get phi. That is 8.84 degrees. Clear, guys? Okay. Okay. Is it clear up to here? Now next step. Now next step is to find out FQ. FQ. Now what is FQ? Can anybody tell me what is FQ? Now you have find phi, you have find FP. तुम्हाला FP मिळाला, phi मिळाला, FQ. FQ is nothing but a force acting along what? FQ is nothing but a force acting along the connecting rod. So what is the formula for FQ? Anybody remembers? So it is nothing but FP upon cos phi. It is nothing but FP upon cos phi. Now we know what is FP. Okay, we have calculated FP. What is FP? Yes. What is FP? What we have calculated FP? 183, sorry, 187, no? Sorry,
18397.
18397. Wait. Remember this. Exactly, I don't know what you have what I have calculated back because I don't have a calculated values. Okay, so FP we have calculated 18397. Okay, as you say, and then what is cos? Cos phi means nothing but a cos 8.84 degree. Okay, so we are getting some value of Fq. Okay, so calculate, you are getting some value of Fq. Okay, now next is Ft. What is Ft? Ft is nothing but a tangential force acting. Okay, it is nothing but a tangential force which is perpendicular to the crank radius. So Ft is a formula. Ft is nothing but a Fq into what? Sine theta plus phi. So you have to calculate. This is a homework now. Fq into sine theta plus phi. Now you calculated Fq. Okay. Similarly, once you calculated Fp, what is the final aim? You have to calculate T. T is nothing but what? Turning moment or torque acting on the crankshaft. So this is next point, and this is next point. So what is torque acting on the crankshaft? Ft into R. So if anybody is able to calculate, if anybody is having a calci, you can tell the values. Okay. So finally, what they have said, they have told you to calculate the effective turning moment on the crankshaft. Means they have told you to calculate the T. So in this way, I will get my final answer. Okay. So I know the final answer. So Ft you are getting 3021.6 Newton meter. Okay. So this is nothing but Fe. So before that, first of all, calculate what is Ft and what is Fu. Okay. I guess Fq you will get. Fq you are getting 18600. According to my calculation, Newton you will get, and Ft I think you will get 13530. 135. If I calculate 13530. Okay. So I am getting such value. So now tell me, have you understand this or not? आता मला मेसेज करा तुम्हाला प्रॉब्लेम समजलाय का, कसं सॉल्व्ह करायचं. Hello, shall I move to the next problem? Hello, बाबू बोला पटकन, मेसेज करा समजलंय नाही समजलंय प्रॉब्लेम, का डाऊट आहे का, एम आय ऑडिबल? Yes, Saurabh, Rajendra, Dattavbhushan, the regular members, all 27 regular members. So only 25 to 25 students are regular, and some students joined at the end of the. That is okay. Chalo. So one more problem. See, I have uploaded the notes. So in the notes on a Google Classroom, I have solved 5 to 6 problems. So it is not possible for me to solve all the problems here. Please go through all the 5 to 6 problems. They are sufficient. Maybe 7 to 8 problems are there total. Okay. So next problem. The obliquity ratio of a vertically placed engine is 4.5. Okay. So they have given n is equal to 4. Now they have directly given you the n is equal to 4.5. What is n? N is nothing but the n upon r. The engine bore and the crank radius are 60 mm and 40 mm respectively. Okay, so they have given you this D is equal to 60 mm. Engine bore. Now try to understand that engine bore is nothing but engine bore is equal to cylinder diameter. Try to understand. Okay, cylinder diameter. Okay, and 40 and the crank radius. Crank radius means what? They have given you R. They have given you R. R means what? 0.04 meter, 40 mm. And MR. The mass of the reciprocating part is 1 kg. So MR. MR means what? Mass of the reciprocating part. The difference in the gas pressure on the two sides of the piston is 5 bar. Now guys tell me what they have given you. Difference दिलाय म्हणजे काय दिले त्यांनी? P1 दिलाय, P2 दिलाय का PG दिलाय त्यांनी? तुम्ही सांगू शकेल what they have given?
PG.
Yeah, they have directly given you the PG. So PG is nothing but how many? 5 bars. Okay. They have given you in the bar. You have to convert that. Okay. PG 5 bar. Okay. बघा आता ह्या प्रॉब्लेम मध्ये त्यांनी डी दिलाय. डी म्हणजे तुम्ही ह्याला कॅपिटल डी घेऊ शकता, स्मॉल डी घेऊ शकता. तुम्हाला एवढं कळलं पाहिजे का डी म्हणजे काय? इट्स अ सिलेंडर डायमीटर. ओके. आता ही स्मॉल डी किंवा स्मॉल डी दिलेलं नाही, म्हणजे पिस्टन रॉडचा डायमीटर दिलेलं नाही याच्यामध्ये. आता पिस्टन रॉडचा डायमीटर जर दिला नसेल तर आपल्याला तो मागचा फॉर्म्युला आपल्याची गरज नाहीये. ओके. We will neglect that. Try to remember this. Okay. Next. आणि काय दिलंय? And the effective gas pressure acts downward. Effective gas pressure acts downward means what? ह्याचा तर स्ट्रोक कुठला आहे तुमचा? स्ट्रोक डाउनवर्ड स्ट्रोक आहे. Towards the crankshaft, and when the crank has moved 50 degree from the TDC position. Yes. येस सौरभ.
सर तो डी सर डी दिलाय की आर दिलाय आपल्याला?
कुठला कुठला
60 mm रेडियस आहे ना? 60
तर
mm.
इंजिन बोर म्हटलंय ना, तर इंजिन बोर अँड क्रँक रेडियस 60 mm अँड 40 mm रिस्पेक्टिव्हली. म्हणजे पहिला आहे तो इंजिन बोर आहे म्हणजे सिलेंडर डायमीटर, आणि दुसरा आहे तो क्रँक रेडियस आहे म्हणजे आर.
ओके ओके सर.
ओके. आणि and when the crank has moved from 50 degree from the TDC, okay, 50 degree from the TDC म्हणजे आणि हा काय दिलाय तुम्हाला थीटा दिलाय. ओके, इज इट क्लिअर? चलो जाऊया पुढे. आणि काय म्हटलंय, डिटरमाइन द पिस्टन एफर्ट, लोड ऑन द गजेन पिन अँड द क्रँक पिन. आता तुम्हाला हे ओळखलं पाहिजे, लोड ऑन द गजेन पिन अँड द क्रँक पिन म्हणजे कुठला लोड आहे, सिलेंडर वॉल थ्रस्ट म्हणजे काय, अँड थ्रस्ट ऑन द क्रँक बेअरिंग. मला सांगा रे, मी तुम्हाला हे ऑलरेडी थेरी एक्सप्लेन केलं. सांगा लोड ऑन द गजेन पिन म्हणजे काय. अच्छा, पिस्टन एफर्ट म्हणजे FP. ओके, लोड ऑन द गजेन पिन अँड द क्रँक पिन म्हणजे काय, कोणी सांगेल मला. नेट लोड ऍक्टिंग ऑन द गजेन पिन अँड द क्रँक पिन म्हणजे काय कॅल्क्युलेट करायचंय. नेट लोड ऑन द गजेन पिन, हे मी तुम्हाला सांगितलं. नेट लोड ऍक्टिंग ऑन द गजेन पिन अँड द क्रँक पिन, याचा अर्थ काय, नेट लोड ऍक्टिंग ऑन द गजेन पिन मीन्स व्हॉट, द फोर्स विच इज ऍक्टिंग along the crankshaft. So what is the force which is acting along the crankshaft?
FP.
FQ. Along the connecting rod. Very sorry. Along the connecting rod. Load on the gudgeon pin is nothing but a load acting on force acting along the connecting rod. And the crank pin. Crank pin means what? FT. Okay. Crank pin means FT. नेट लोड ऍक्टिंग ऑन द क्रँक पिन म्हणजे क्रँक पिन एफर्ट झाला, FT झाला. आणि सिलेंडर वॉल थ्रस्ट म्हणजे काय, म्हणजे काय, FN. येस. आणि द थ्रस्ट ऑन द क्रँक बिअरिंग, म्हणजे FR म्हणजे काय, रॅडियल फोर्स. बघा ना, दोन फोर्स आहेत ना, FQ जर असेल तर दोन फोर्स आहेत. Shall I show you the diagram? Or can you imagine which are the two forces? FQ is divided into two forces. No? One is a perpendicular force FT, and another is a radial force FR. So radial force FR is nothing but it creates the thrust on the crank bearing. हे मी तुम्हाला सांगितलं, व्हिडिओ नीट बघा. ओके, and load on the gudgeon pin म्हणजे FQ झाला, आणि सिलेंडर क्रँक पिन एफर्ट म्हणजे FT झाला. ओके. So it is very important you remember diagram. Okay, so let's move. So, okay, so given P1 minus P2 is equal to Y bar. So you know na how to convert. So 1 bar is equal to 10 raised to 5 Newton per meter square. So 5 into 10 raised to 5 Newton per meter square. Okay, so that is equal to 0.5 Newton per mm square. Theta 50 degree, N 300 RPM. So omega is equal to 2 pi 60. WR. Now what is WR? MR into G. MR is 1, so 9.8 Newton. What is sin phi? Sin theta upon n. So Fi is equal to 9.80. So this is a basic thing what we know. Right? Okay. Is it clear? इथपर्यंत जाऊया पुढे. ओके, भाऊ इथपर्यंत समजले का? जाऊया पुढे. आपल्याला अजून बरेच प्रॉब्लेम सॉल्व्ह करायचे. ओके, चलो. सो नेक्स्ट, फर्स्ट स्टेप नंबर 1, piston effort. So tell me the formula for the piston effort. FP. Anybody? Yes, tell me the formula for the piston effort. Chalo fast. What is FP? FL
plus minus FI.
Not plus minus कशाला, मायनस घेणार की प्लस घेणार? एनीबडी? मायनस और प्लस? मायनस ना, एक्सलेटिंग आहे, मायनस FI. आणि प्लस की मायनस WR?
प्लस.
हे तुम्हाला मी सांगितलंय परवाच्या लेक्चरला. जर नसेल तर लक्षात घ्या, मी परत सांगतो, एकदा परत बघा. हॉरिझॉन्टल इंजिन असेल, कसं लक्षात ठेवायचं, हॉरिझॉन्टल इंजिन असेल आणि ते व्हर्टिकल इंजिन. मी तुम्हाला एक डिफरन्स सांगतो, हे लक्षात ठेवा. आय नो इट्स कन्फ्युजिंग. let us say horizontal engine, let us say vertical engine. Okay. So in case of the horizontal engine, when they say that piston is moving from, when the piston is moving from IDC to ODC, right? Just लक्षात ठेवा. What will happen? The parts will accelerate. Parts will accelerate. And when the piston moves from ODC to TDC, sorry, ODC to IDC, parts will retard. Parts will retard. Now just tell me, in case of the horizontal engine, when the piston is moving from IDC to ODC, accelerating ahead, so what do you take, plus sign or minus sign? Be fast. Yes? Minus sign. Okay. And when piston is moving from ODC to IDC, plus sign. Okay? Clear? आता वर्टिकल इंजिन मध्ये कसं लक्षात ठेवायचं, जेव्हा पिस्टन तुमचा टीडीसी, when the piston is turned, त्यांनी सांगितले ना, piston is turning from TDC to PDC, म्हणजे piston is turning from the TDC, म्हणजे याचा अर्थ the angle is turning from TDC, that is a theta angle, म्हणजे तो TDC पासून तो BDC ला जाणार. So the parts are accelerating, so take minus sign. आणि वाईस वर्सा असेल BDC to TDC, ओके, सो टेक प्लस साइन, जो पार्ट्स आर रिटार्डिंग. ओके, आता मागच्या प्रॉब्लेम मध्ये पण तू टीडीसी पासून मूव्ह होत होता, त्यांनी सांगितलं ना अँगल इज टर्निंग फ्रॉम द टीडीसी. ओके, आता ह्या केस मध्ये पण त्यांनी काय सांगितलं प्रॉब्लेम मध्ये, द क्रँक हॅज मूव्ड 50 डिग्री फ्रॉम द टीडीसी, म्हणजे क्रँक तुमचा 50 डिग्री टीडीसी पासून मूव्ह होते, म्हणजे तुमचे पार्ट्स काय होतात त्याचा अर्थ एक्सेलरेट होणार आहे. सो यू हॅव टू टेक साइन मायनस. आणि डाऊनवर्ड स्ट्रोक असेल आणि अपवर्ड स्ट्रोक असेल तर प्लस मायनस. आता मला सांगायचं तुम्हाला क्लिअर झालंय की नाही, सो आय कॅन मूव्ह फॉरवर्ड. Clear? Yes or no? Be fast, guys. So I have to solve at least one problem on equivalent dynamical system. चलो.
Yes, sir.
ओके ओके. सो हे लक्षात ठेवा व्यवस्थित. ओके, आणि मी असं होत नाही, आणि मी तुम्हाला काय सांगते की काहीच दिलं नसेल, अगदी नो डेटा इज गिवन, कन्सिडर एज अ एक्सलरेटिंग, पण असं होत नाही, काहीतरी तुम्हाला डेटा दिलेला असतो त्याच्यामध्ये. यू हॅव टू रीड आउट प्रॉपरली. ओके, चलो. सो फर्स्ट ऑफ ऑल लेट्स फाइंड एफपी. सो एफपी इज इक्वल टू एफएल minus Fi, now this is clear, plus WR. Okay, now first of all calculate FL. Now anybody tell me how you calculate FL? How will you calculate FL? Pi by 4 into d square into PG, right? बरोबर ना? FL how will you calculate? Pi by 4 into d square into PG. Okay, now guys I am not going to calculate. हे तुम्हाला मी हा प्रॉब्लेम तुम्हाला सॉल्व करा, मी तुम्हाला डिस्कस करतो. ओके, सो फर्स्ट ऑफ ऑल calculate FP. Sorry, first of all calculate FL. Okay, now FL is nothing but pi by 4 into d square. D तुम्हाला माहिती आहे, PG माहिती आहे. D म्हणजे काय, सिलेंडर डायमीटर. लक्षात घ्या, तुम्हाला कन्फ्युजन नको असेल तर मी कॅपिटल D घेतो. चला, I will take a capital D. Okay, so pi by 4 into d square. Clear? Next, त्याच्यानंतर मग परत FI, FL कॅल्क्युलेट. FI कसं कॅल्क्युलेट करणार सांगा. What is the formula for FI? MR into, what is the formula for FI? MR into, अरे बोला, फॉर्म्युला पाठ पाहिजे एफ आय चा. एमआर इंटू
ओमेगा स्क्वेअर इंटू आर.
इंटू आर नाही बाळा, ओमेगा स्क्वेअर आर बेस्ड आर, म्हणजे याचा अर्थ काय, इट्स अ यू कॅन से अँग्युलर वेलोसिटी ऑफ ए रेसिप्रोकेटिंग पार्ट. सो ओमेगा आर म्हणजे ही 31.41, हा ओमेगा म्हणजे तुमचा ओमेगा आर आहे, लक्षात घ्या. Okay, into cos theta plus cos 2 theta upon n. Clear? So calculate Fi. Fi calculate केलं. Next, पुढे आता काय करणार, पिस्टन एफर्ट कॅल्क्युलेट करा. पिस्टन एफर्ट FL माहिती आहे, Fi मिळाला, WR तुम्हाला माहिती आहे. ओके, चलो नेक्स्ट. आता हे झालं की नेट के सांगितलं, त्यांनी काय सांगितलं, नेट लोड acting on gauge P. Net load acting on gauge P. So remember that net load acting on the gauge P is always equal to, is nothing but a force acting along connecting rod. Force acting along connecting rod. So it is nothing but a FQ. Force acting along connecting rod is nothing but FQ. It is to the base FQ. Okay. Now tell me what is the formula for FQ? FQ is equal to FP upon cos phi. Okay. Have you understand it? Take FP in Newton, सगळं न्यूटन मीटर डिग्री रेडियन पर सेकंड, युनिट समजले का, न्यूटन पर मीटर स्क्वेअर डिग्रीज रेडियन्स. ओके, सो कॅल्क्युलेट दिस न्यूटन. त्याच्यानंतर नेट लोड ऑन द क्रँकपिन, त्यांनी काय म्हटले, नेट लोड ऑन द क्रँकपिन. सो थर्ड केस, नेट लोड ऑन द क्रँकपिन. So find this net load on the crankpin. Yeah. So what is net load on the crankpin? Ft means what? The force perpendicular to the crank. So net load on the crankpin means what? It's a crankpin effort. त्याच्यामुळे crankpin effort तयार होतो. तो काय? Ft is equal to काय फॉर्म्युला Ft चा? बोला, Ft चा फॉर्म्युला काय? What is the formula for
FQ
Ft?
sin theta plus phi.
FQ sin theta plus phi. ओके, हे सगळं तुम्हाला कॅल्क्युलेट करायचंय. झालं? ठीक आहे, हे कॅल्क्युलेट केलं. हा पण कशामध्ये येणार? न्यूटन. न्यूटन. ओके, चलो नेक्स्ट. आणि पॉइंट नंबर 4, सिलेंडर वॉल थ्रस्ट. सिलेंडर वॉल थ्रस्ट म्हणजे काय? नॉर्मल रिएक्शन थोडक्यात. सिलेंडर वॉल थ्रस्ट इज नथिंग बट Fn. चलो, व्हाट इज द फॉर्म्युला फॉर Fn? Fn is equal to Fq. Fq is equal to Fp upon cos phi. Fn is equal to Fq sin into phi. So you find this into the Newton, right? See, खूप सोपे आहे हे प्रॉब्लेम, स्ट्रेट फॉरवर्ड आहे. आता उद्यापासून आपण मेकॅनिकल व्हायब्रेशन चालू करू. तिथे तुमच्या लक्षात येईल की तिथे फिक्स काहीच नसतं, प्रत्येक वेळी लॉजिक चेंज होतं. सो यू हॅव टू डेव्हलप युअर लॉजिक इन मेकॅनिकल व्हायब्रेशन. बट इन फर्स्ट 2 मॉड्यूल्स द फॉर्म्युलाज आर कॉन्स्टंट. ओके, अँड लास्ट, thrust on the crank bearing. What is thrust on the crank bearing? Thrust on the crank bearing. Yes, thrust on the crank bearing nothing but the radial force, Fr. So Fr is equal to Fq cos theta plus phi. Okay, and last cramping effort or the torque acting on the connecting rod. Torque acting on the crankshaft. What is that? Ft into R is equal to Newton meter. आता मला सांगा बाळांनो, तुम्हाला हा प्रॉब्लेम कळला का? सगळ्यांना हा प्रॉब्लेम कळले दोन्ही? ओके, so there are a lot of problems you can easily solve. मला सांगा, तुम्हाला प्रॉब्लेम्स कळले का सगळ्यांना? मेसेज करा, येस और नो. येस और नो मेसेज करा. हॅलो, ओके, चलो आता एक शेवटचे 10-5 मिनिटात आपण इक्विव्हॅलेंट सिस्टीम वरती प्रॉब्लेम सॉल्व्ह करूया पटकन. ओके, चलो, सगळ्यांसमोर स्क्रीन आली आहे बघा. A suspended rod, a connecting rod is suspended from a point 25 mm above the center of small a. ओके, काय केलंय? A connecting rod is suspended. आता हा प्रॉब्लेम कुठला आहे? इक्विव्हॅलेंट डायनॅमिकल सिस्टीम वरती. ओके, a connecting rod is suspended from a point 25 mm above the center of small end and 650 mm above its CG. Its mass being 37.5 kg, when permitted to oscillate, TP is found to be 1.87 seconds. Find the dynamically constituted of two masses, one of which is located at the small a. Okay, so first of all, guys, you have to draw this figure. Okay, now you draw this figure. First of all, draw the figure of connecting rod. So this is nothing but a small end. This is nothing but a big end. Okay, now what they have said, a connecting rod is suspended from a point 25 mm above the center of small end and 650 mm above its CG. याचा अर्थ काय होतो? ह्या वाक्याचं हे वाक्य बघा. A connecting rod is suspended from a point 25 mm above the center of the small end and 650 mm above its CG. म्हणजे ह्याचा अर्थ काय की तुमचा हा जो स्मॉल एंड आहे, हा स्मॉल एंडचा तुमचा सेंटर आहे. म्हणजे स्मॉल एंड तुमचा सेंटर पॉईंट हा O झाला, पण तो ह्या O पॉइंटला सस्पेंडेड नाहीये. तो सस्पेंडेड कुठे आहे? या O पॉइंटच्या वरती 25 mm अबाव. कळलं? म्हणजे कळलं तुमचा हा जो पॉइंट आहे, या 2 पॉइंट मधलं अंतर किती आहे? 25 mm. समजलं? म्हणजेच तुमचा हा जो कनेक्टिंग रॉड आहे तो ऑसिलेट होतोय ना. मी काल तुम्हाला कंपाऊंड पेंड्युलम सांगितलं, इट इज ऑसिलेटिंग. So it is oscillating at a point of suspension O, but that point they are saying it is 25 mm above the small end. म्हणजे तुमचा पॉइंट ऑफ सस्पेन्शन कुठे आहे? इथे आहे. 25 mm above the small end. हा स्मॉल एंड सपोज O डॅश असेल. ओके, आता आपल्याला हे माहिती आहे की डिस्टन्स बिटवीन द पॉइंट ऑफ सस्पेन्शन O and CG is nothing but the edge, right? The distance between the point O, point of suspension, and the center of gravity of this connecting rod or the GD body is nothing but the edge. Is it okay? So this total distance is nothing but the edge. Okay. मग हे total distance h त्यांनी किती दिलंय? त्यांनी काय म्हटलंय? rod is suspended from its point 25 mm above the center of small end and 650 mm above its CG. म्हणजे h किती दिलाय? h दिलाय 650 mm. क्लियर? म्हणजे तो झाला 0.655 मीटर. इज इट क्लियर ऑर नॉट? ओके. आणि त्यांनी काय दिलंय? मग L1 म्हणजे काय असतं तुमचा? L1 इज नथिंग बट अ लेंथ. कुठली लेंथ? द लेंथ, लेट अस से दिस इज अ स्मॉल एंड हॅव्हिंग अ मास m1 अँड हॅव्हिंग अ मास m2. आपल्याला काय करायचंय? आणि ही तुमची रिजिड बॉडी आहे ना, रिजिड बॉडी हॅव्हिंग अ मास m. ओके. आता आपल्याला डायनॅमिकली इक्विव्हॅलेंट करायचंय. So to make this system dynamically equivalent, we have to satisfy the three conditions, right? So for that, let us start. So they have given h is equal to 650 mm, that is equal to 0.655 meter. L1 is nothing but a distance between the center of mass of M1 and the CG. हे लक्षात ठेवा. L1 म्हणजे काय असतं? Distance. ओके. बिटवीन द स्मॉल एंड चा सेंटर म्हणजे मास M1 चा सेंटर आणि CG. तो किती असणार आहे मला सांगा. आता तुम्ही सांगू शकता मला तो किती असणार आहे L1. L1 will be 650 minus 625. 625. ओके. सो 0.625 मीटर. ओके. आता कधी कधी लक्षात घ्या, कधी कधी जर तुम्हाला दिलेलं असेल की द पॉइंट ऑफ सस्पेन्शन इज ऍट द CG ऑफ और ऍट द सेंटर ऑफ M1. सो रिमेंबर दॅट H विल बी इक्वल टू L1. हे लक्षात ठेवा. आता हे तुम्हाला काही प्रॉब्लेम मध्ये दिलेलं असेल. ओके. इज इट क्लिअर? पण ह्या प्रॉब्लेम मध्ये तसं नाहीये. मग तो प्रॉब्लेम इझी असतो सॉल्व्ह करायला, पण ह्या प्रॉब्लेम मध्ये म्हणून मी हा प्रॉब्लेम घेतला. ओके. नेक्स्ट, दे हॅव सेड दॅट M इट्स मास इज म्हणजे M द मास ऑफ ए कनेक्टिंग रॉड. M1 त्यांनी दिलाय 37.5 kg म्हणजे मास ऑफ ए रिजिड बॉडी और M दिलाय. ओके. व्हेन परमिटेड टू ऑसिलेट TP इज फाउंड टू बी म्हणजे टाइम पिरियड तुम्हाला दिलेला आहे 1.87 सेकंड्स. ओके. बघा काय काय दिलंय. ओके. फाइंड द डायनामिकल इक्विव्हॅलेंट सिस्टीम. म्हणजे थोडक्यात तुम्हाला काय सांगायचंय? यू हॅव टू फाइंड आउट M1 अँड यू हॅव टू फाइंड आउट M2. सो यू हॅव टू फाइंड आउट M1 अँड M2. आता गाईज मी तुम्हाला सांगितलं होतं की फर्स्ट ऑफ ऑल व्हॉट इज द कंडिशन फॉर द सिस्टम टू बी डायनामिकली इक्विव्हॅलेंट? K स्क्वेअर शुड बी इक्वल टू L1 into L2, राईट? त्याच्यातला आपण L1 हा आर्बिट्ररी सिलेक्ट करतो. L1 आर्बिट्ररी सिलेक्ट करतो अँड फ्रॉम K वी फाइंड L2 अँड देन वी फाइंड M1 अँड M2 अँड देन वी सेड दॅट द सिस्टम. बघा ना, तीन कंडिशन्स आहेत. त्या तीन कंडिशनच्या अनालिसिस वरून मला फॉर्म्युला मिळाला. आता ह्या केसमध्ये L1 त्यांनी तुम्हाला ऑलरेडी दिलेला आहे. जर दिला नसेल तर तो आपण आर्बिट्ररीली चूज करतो. बट फॉर सॉल्विंग अ प्रॉब्लेम नॉर्मली युअर L1 or L2 either is given, so you can find K. From K you can find L2 and then you can find M1 and M2. So basically for the system to become a dynamically equivalent, you have to find out first of all L2 and then you have to first of all you have to find out K. L2, L1 is given and then you will get M1 and M2. So now I have to find out K, I have to find out M1 and I have to find out L2 and I have to find out M2 so that the system is dynamically equivalent. Very very important. मला सांगा बाळांनो, तुम्हाला हे क्लिअर झालं का? ओके. क्लिअर झालं का मला सांगा. इथपर्यंत क्लिअर झालं? अरे बोला ना, इथपर्यंत क्लिअर झालं का? हॅलो. अरे तुम्हाला क्लिअर झालं का? मी काय विचारतो?
Yes, sir.
माझा आवाज येत नाहीये का रे तुम्हाला व्यवस्थित? ओके. बरं. नाव टेल मी. नाव आय वॉन्ट सम आन्सर फ्रॉम युअर साइड that K is not given. The radius of dilation is not given. So if K is unknown, L2 is unknown, and we just know L1. So how will you? So because there are two unknowns now, we know that K square is equal to L1 and L2, but we have two unknowns. Okay, and we know that I is equal to MK square. We know M, but again I is unknown. Now tell me, how will you find out K? Okay, how will you find out first of all K? Since we don't know, एक डायलॉग लिहायचा. सिन्स वी डोंट नो K. ओके. सो काय करायचं? मी तुम्हाला काल एक थेरी शिकवली. कुठली थेरी? कंपाऊंड पेंडुलमची. ओके. सो व्हॉट यू हॅव टू डू? कन्सिडर. ओके. Consider, because see this connecting rod is also an example of a compound pendulum, na? If you take this connecting rod like this, you know that this will oscillate, This will accept from this point to this point. Okay. So this connecting rod is nothing but a rigid body. So it is oscillating at the point of suspension O, oscillating about by angular displacement theta. So vibrations are created, oscillation is done. So this connecting rod is nothing but a compound pendulum. Na? So this connecting rod is one sort of compound pendulum. So when K is not given, try to remember that, or remember that you can consider this as a compound pendulum. Very, very important. So I have already explained the theory of compound. So consider this connecting rod as a compound pendulum. Connecting rod system is known as a compound pendulum. Now tell me, you have already derived a formula for a compound pendulum. Now tell me, for a compound pendulum, what is time period or what is length, LE? What is LE for compound pendulum? Already we have derived. चला सांगा मला LE काय? बोला, आपल्याला प्रॉब्लेम संपवायचा आहे. 12 वाजले. Tell me, I have already derived the formula na yesterday. So what is LE for compound pendulum? And you should remember this. We have already derived. Yes, LE, length of a simple pendulum, LE. Nahi.
K square plus h square upon h.
Okay, LE is equal to K square upon.
K square plus h square upon h.
Okay, so LE is equal to K square plus h square upon h. Okay, so is it correct? Is it correct or not? First of all, anybody? Hello? Okay, it is correct, na? And now we know what is again. Okay, now so what is omega n then? What is omega n? Okay, what is omega n? G upon L, right? What is omega n? Formula remember for omega n. It is nothing but a G upon L. Okay, mass upon length. Okay, so put this omega n. What you are getting? G up. So LE. So what you will get? G into H, right? G into H. So LE. This is nothing but a LE. So G. See how I am remembering this. So G into H upon what I will get? K square plus H square, right? Guys, am I correct or not? Okay.
Yes, sir.
Now TP. Now what is time period? Time period is nothing but a 2 pi upon omega n. 2 pi upon omega n, right? So what I will get? 2 pi into what I will get? This will get reverse. K square plus H square upon G into H. Okay. So this is what I have derived. You watch the video. It is very, very important to remember. Okay. So I got this final formula TP is equal to C. So basically, when the radius of gyration is not given, this connecting rod is nothing but a system which is acting as a compound pendulum. Okay, so it is a compound pendulum. So we know that for compound pendulum, LE is equal to this. Natural frequency is G upon LE. So you're getting this. Time period is nothing but a 2 pi upon omega. So this is the formula what I've got. Okay. So now tell me, you know TP. तुम्हाला TP माहिती? Can you calculate K now? Can you calculate K? Hello? बोला बघा K मिळेल का? याच्यामध्ये एकच अननोन आहे ना?
Yes, sir.
So K मिळाला. Okay? So yeah. So we know that TP is equal to 2 pi. Okay? Divided by what I have got G into H. So from this I will get K. Okay? So solve this and you will get K 0.37 meter. So you can directly put into the calci. And you will get a K. Okay? So now if you got a K, now you know that for the dynamically equivalent system, now you know the condition. For the dynamically equivalent system, okay, now I am finishing. For dynamically equivalent, what is the condition? Anybody? K square is equal to L1 upon L2, sorry, L1 into L2. So from this, you will get L2, right? So what is L2 now? Hello guys, fast. What is L2 now? 0.228. Okay, you solve this and it should be in meter. Okay, now M1 is equal to and M2 is equal to, now tell me what is the formula for M1? Anybody? Already we have derived. So what is M1? M1 is nothing but M into L2 divided by L1 plus L2. And M2 is nothing but the M into L1 divided by L1 plus L2. Okay. So this is nothing but the 10 kg and this is nothing but a 27.5 kg.